Here we're going to talk about identifying the period of a trig function. So here I've graphed two cycles of sine, right? So here's one cycle, and then here's the second cycle. Now the period of sine is 2 pi, and so you see people often do this. Well, they don't do that. People often do this. They draw a line like so, with arrows on it, and they say the period is equal to 2 pi. Now that's you have to be a little bit careful with that, because the fact that the period of this graph is 2 pi, or of this function is 2 pi, is not necessarily connected to the 2 pi right there. All we mean by this expression is that you have to go through 2 pi to get to the same place in the wave cycle. Like for example, if I started here at negative pi, I could draw arrows like this. Okay, and that again reflects the fact that the period is equal to 2 pi. Now, notice what happened. You need two things to be true to get to the same place in the cycle. You, of course, have to have the same value, right? So I'm at 0 here, and I'm at 0 there. But notice that I'm also dropping, right? So the graph is decreasing right here and at 0. Here it's decreasing and at 0 as well. So if I start here and I walk, how far do I have to go to get to the same place in the cycle? Well, I'm walking. Not right here, right? Because even though the value is 0, this is increasing right here. So you have to keep going all the way to there, and that is the first point you reach where you're at the same place in the cycle as what you started at. Okay? And that's what we mean when we say the period. It's how far you have to go to get to that same place. And the period of this function is 2 pi. Anywhere you start, right? If you start here and you want to go, to the next place in the cycle, where would you go? You'd go to right there. And that distance is 2 pi. And that's what we mean by the period of a function or of a graph. And we know that if you have, sine, so y equals sine, we know that the period is equal to 2 pi. And we also know the same thing is true with cosine. The period of the cosine function is 2 pi as well. Now what we're going to do here is we're going to look at different functions that are slightly different than these and assess how to get their periods. Let's do that now. So let's take this first example, identify the period. Now this isn't plain old cosine, right? This is cosine of 2x. And whenever you have a number in the argument that you're multiplying x by, that changes the period. Now it turns out you can always get the new period by doing as follows. So P stands for period. You take the old period, well, it's cosine, right? So the old period of plain old cosine is 2 pi. And then you divide that by whatever you're multiplying x by. So I'm multiplying x by 2, so I take 2 pi and I divide it by 2. And whatever you get from this, that gives you the new period. So the new period is pi. What that means is that if you graph this function here, you'll only have to go pi, not 2 pi anymore, but pi to get back to the same place in the cycle. In other words, this function is a little more compressed, right? It oscillates faster than plain old cosine, because I only had to go pi, not 2 pi, to get repetition in the cycle. So, and this pattern will always work. Take the old period and divide by whatever you're multiplying x by. So on this function, I see it's 1/3 sine of 1/2 x. So once again, the period is the old period, right, which is 2 pi. And I know that because I'm looking at sine. And I divide it by the number right here that I'm multiplying x by, which is 1/2. So when I take 2 pi and divide it by 1/2, I get 4 pi. That means I have to go, the new period is 4 pi, but that means it's extended really long, right? That these are really slow oscillations. I have to go twice as far as I had to go with plain old sine. The graph has been stretched out. Now you might be asking, what does this 1/3 do? It turns out that's not connected to period at all. That's going to be for something we call amplitude. And the amplitude is basically the height of the wave. And to get the amplitude, you take the absolute value of whatever number is there. So the amplitude is equal to the absolute value of 1/3, which is just 1/3, okay? So you have to make sure you're choosing the right number when you identify the new period. Let's take another one, just to make sure we've got it. So let's identify the period of y equals 5 times tangent of 3x. Now it turns out we're going to meet some other trig functions, one of which is called tangent. Now tangent is periodic, that is, it repeats just like sine and cosine. Now the graph doesn't look like a wave, but it still repeats. And so to find the period of this function, right, the fact that it repeats means that it's what we call periodic. So you can find the interval over which you have to go to get repetition, called the period. Now you take the old period. Now the old period of tangent turns out not to be 2 pi. It turns out it's just pi. Okay, and we'll see that in future videos. But you take that old period and you divide once again, just like before, by whatever number you're multiplying x by, and in this case 3. So this is the period of this function. It's not pi anymore, it's pi divided by 3. Now notice that plain old tangent has the period of pi, right? That's not 2 pi like sine and cosine. So it turns out tangent, you get repetition faster than you would with sine or cosine. Okay, one more here. The period of this function, tangent of 1/3 x. So the period is going to be, well, the old period of tangent, which is going to be pi, as we're going to see, and you divide it by whatever you're multiplying x by, so by 1/3, and you get 3 pi. That's the new period of this function. Okay, so that's how we identify period, and we're going to be using that when we begin graphing. Until next time.